Hi, in this video we are going to implement depth-first search with the help of recursion. So I'm going to have a private method, private void DFS recursive. It's going to wait for a vertex. Here I'm going to call this DFS recursive because we can have as many clusters again as we want. And no matter we implement this depth-first search with recursion, if there is more than one cluster, we have to use something like this. Okay, so first I'm going to system out println the v vertex plus some spacing. We have to consider all the neighbors of this given vertex. So vertex v dot get neighbor list. Again, we have to check whether this vertex has been visited or not. So is visited. And if we haven't visited this vertex, then we are going to visit it. So first we set visited true because we visited right now. And then we are going to call this DFS recursive method on this vertex recursively. It's very important that I'm not sure whether you are familiar with memory management and what's the difference between stack memory and heap memory, but basically the operating system is going to use the stack memory for these kinds of recursive method calls. So no matter that we don't use a stack abstract data type as we have used it here, the operating system is going to use a stack like this. So basically, depth-first search is going to be implemented with the help of a stack with this implementation, but we are going to delegate this problem to the operating system, and the stack memory is going to be piled up with these DFS recursive method calls. Okay, let's see whether it's going to give the same solution. 1, 2, 3, 4, and 5. You may come to the conclusion that, okay, it is not the good solution, but basically it is the good solution because no matter what, that we can visit the vertex 2 or the vertex 3. There is no order in graph traversing. So we visit the vertex 2, and because the vertex 2 has no other children, as you can see, then we are going to recurse back and we are going to visit the other child, which is the v3. The v3 has the child v4, v4 has the child v5, so basically it is a valid order. And if you want to get a good grasp of depth-first search and breadth-first search, you have to construct your own tree-like structures or whatever graph you would like to construct, and you have to play around with these kinds of algorithms for a while to be able to get a good grasp. But what's very important that if we have a vertex and the vertex has a left child or a right child, then the order doesn't matter, that we first visit the left and then the right, or we visit the right child first and then the left child. Basically, this direction does not matter. Okay, so basically that's all about the recursive implementation of depth-first search. To be honest, I prefer the recursive depth-first search because it's much more compact. But what's very important that at the lowest level, a stack is going to be used, but it's going to be handled by the operating system, so we don't have to bother about it. But whenever we use recursion, then there is a stack at the lowest level. Okay, the operating system is going to do everything for us, and that's why, as far as I am concerned, recursive method calls are very, very convenient because most of the problems are delegated to the operating system, and most of the times the operating system is working fine. Thanks for watching.